In this video, let's discuss what an inverse machine or inverse function is, or how does it look like. So this is a simple diagram to demonstrate what an inverse function looks like. Now when you say a function is something that when you pick an input, right? I'm calling these guys input, then you have to plug that into certain machine to get the output. So that is how simple what a function works. So let's say this apartment here is the children's apartment, and then you have the mother's apartment. So we are picking the children from their apartment and then plug them into certain machine to get their mothers, right? So that is very simple. So the children here, you put them into certain machine, then the image of their mothers will appear on the screen. So input, machine, and then output, right? Input, machine, and output. So that's how simple a function works. So what about the other way around? So let's say we have the mothers and then we want to determine their children. Is that okay? So if it goes like this, it means that the children are the input. You are putting the children inside a machine to determine their mothers. But when it comes the other way around, so you are going to use the mothers as the input and then put them into a different machine to get what their respective what children, right? So that is very simple. So when you are starting from the mothers, it means that we are going the other way around. So the vice versa. So that is why we came up with what the inverse machine. So that's the inverse function. Is that okay? So when you use the children as what the input, then that is the straightforward. So when you use the mothers as well the input, then we are going the other way around, right? So that is the inverse of function or machine. So how do you determine that? So let's use this example to know how to calculate what the inverse of functions. Now this is a very simple example. So this is a pure past question here, right? So this is a pure past question. That says that you should be familiar with this notation. So what it means is that this is the function. We are picking the child. The child is the x. You have to plug the child inside this machine to determine what his or her mother, right? So once we pick this child and put it inside a machine, then the image of the mother will appear on the screen. Is that okay? So this is what I mean by the machine. So I have 5s minus what 9. The x here is the child, right? So any child that I will pick, I have to put that child inside this machine to get their corresponding what image of what their mothers, right? Okay, now we know that is just a straightforward one. So what about if you have the mothers, then you want to determine their children? So that should be the inverse function. So here this example says that we should find the inverse of what this function. Is that okay? So we are going to use them. We are going to find a machine that determines the children of what their mothers. So we are using the mothers as the input. We are plugging the mothers inside the machine to determine what their children. Okay. Now the way of solving these things is that you can just let this f of s. This f of s means that this is the machine that determines what the mothers, right, by plugging in the chart. So this is what we have been given. So we start with what we have been given. So the f of s, let f of s is equal to y over here, right? Let f of s is equal to y. So the reason is that we don't want to work with this guy, right? A little bit complicated. So when we are working with a single variable, so we can easily determine that. So this is the mother, right? This is the mother here. So let's call the mother y, and then the child is the x, right? The child is the x, so y is the mother, and then the child is the x, right? Okay. Now, what are we looking for? We are looking for the machine that what determines what the children by putting their mothers inside the machine. So you can see this is the child. At the beginning, we are putting the child inside the machine to determine their mother. So the vice versa will be what? We are placing the mother inside a machine to determine what their children. So you need a different machine to do that. So that machine is what exactly we call an inverse function. So how do you do that? You just let the beginning of the function to be what? Y. So consider this y is the mother here, but y is equal to, you are just replacing from here. So this y will be equal to 5x minus 9, right? So y is equal to 5x, meaning the mother is equal to 5 multiplied by the child minus 9. Is that okay? Just for understanding purpose. Look at something. Now we know that this here, it means that we are putting the child inside the machine to determine the mother, right? We are putting the child inside this machine to determine. That is not what we are looking for. we are looking for the situation whereby we can place the mother inside the machine to determine what their children, right? So we need this guy to be here. Is that okay? We need this guy to be inside the machine. Now this is how you should solve that. So for that reason, let's interchange this guy, right? Let's interchange the mother and the child, because we have to plug in the mother inside the machine to determine what his her child, right? We have to plug the mother inside the machine to determine what the child. So you interchange the x and y. So when you interchange the x and y, what happens? We are just using the same machine. We don't want that. Is that okay? We are interchanging the variables here because we want the mother to be what? Be the input. The mother will be the one that we place inside the machine before her child will appear on what? Our screen. Okay, so now you have placed the mother inside the machine. So the machine that we are using is the same machine of what? The children. We don't want that. Is that okay? We don't want that situation. Therefore, you have to make sure that the mother stands out, right? So after interchanging, we can see that it's the mother that we are placing inside the machine. We don't want that. We don't want that same machine as the machine of the children. So for that reason, you need to solve for the mother to stand out, right? So by solving for the y, the mother here tells you that whatever you get will be the machine of the mothers. Is that okay? So here, after interchanging the variables, you can see that here we solve for the y, right? Meaning that we want the mother to stand out, because the mother is the one that we are going to place inside the machine. So here will be what? X plus 9 is equal to 5y, right? We are solving for y. So what do? You divide both sides by 5. You can see that you divide both sides by 5, you arrive at what? X plus 9 all over what? 5 is equal to y. So you can see that now y here, the mother has stand out. Is that okay? So the mother stand out. So this will be the machine that we can plug in what the mother to determine what their children. Is that okay? So when we rearrange this, you can see that y is equal to x plus 9 all over what? 5. What do? This is just the notation for what? The inverse. Is that okay? This is just the notation of what? Inverse. So f raised to the power minus 1. This is just the notation of inverse machine, right? Okay. So this is the f inverse is equal to what? 1 over 5 or into bracket s plus 9. So this machine is the machine for what? The mothers, right? When you plug the mother inside this machine, the picture of what her child will appear on our screen. So that is how simple you find what? The inverse of what? A function being given. So at the beginning, you have to make sure that you have the original function. So that is where we are plugging in the child into the machine. Then you let that y is equal to what? 5x minus 9. Is that okay? So what do? You have to interchange the variable because we want the mother to be the one that we will put inside the machine. Very, very simple. Okay, then you proceed and solve for that. So let's look at this second example here. So this second example here says that h of s is equal to that 2s minus 1 all over what? 3 minus x. So where is the x coming from? The children, where are they coming from? They are coming from what? This house, the house of r. That is the real numbers, right? And then we don't want s to be what? Equal to what? 3, right? We don't want that. You know what will happen? Boom, this will be 0. We don't want that. Okay, now let's say you find the inverse as well as what? The largest possible domain of what? This function. So this is a pure exams question, right? So what do? You first of all let the h of s is equal to y. We know the reason why we are doing this. We don't want to work with this guy. Is that okay? We are just replacing the h of s here by what? Y, right? So this is the mother here. We know that when you plug the child inside the machine, it will give you the mother. So the mother is here. So y is equal to 2s minus 1 all divided by 3 minus x. So what do? You interchange the variable. You know the reason why we are interchanging, because we need the inverse function. We need a function or a map that when you plug the mother inside that machine, the name of the child will appear on our screen. So we need to interchange that, because the original one gives us the reason that we have to put the child inside that machine to determine the mother. But here we are looking for the machine that will help us to determine the child when you place the mother inside the machine. That is the reason why we are interchanging by opinion, right? Okay, now let's move on. So for that reason, you can see that when exchange the s and the y from here we are just replacing. Let the s come here and the y goes here, right? Okay, so when you exchange, you get something like this. S is equal to 2y minus what? 1 all divided by 3 minus y. So what are we looking for? We are looking for y. That is the matter. We want to place the matter inside the machine. So let the matter stand out so that we can easily see her clearly. Is that okay? So okay, now you need to solve for y. So you do the cross multiplying, nicely you get what? X into bracket 3 minus y is equal to 2y minus what? 1. So when you do a calculation, very perfectly, you consider you arrive at what? 3x plus 1 is equal to y 2 plus what? X. So you divide both sides by what? 2 plus s. 2 plus s and a 2 plus s, then you get something like 3s plus 1 all over what? 2 plus x is equal to y. Is that okay? So this will be the machine that what we can place the matter inside to determine what? Her chart. Right? Okay, next when you get to this point, you just replace this y by the inverse notation. Is that okay? You just replace that by the inverse notation. So this is the same thing. We are just exchanging this y by the inverse notation here. So h inverse is equal to what? 3s plus 1 all over what? 2 plus s. Now the second part says that you should determine the largest possible domain of what? The inverse function. Right? So you should determine the largest possible domain of what? Of the inverse function. So how do you do that? Which type of function is this? This is what? A pure rational function. Is that okay? If you don't know what a rational is, it's something over something, right? So a number on top divided by another number. So how do you determine the domain? Is that okay? The domain here simply means that what can we put inside this machine, then we get an image, right? So anything that we put inside this machine, we have to get the image out. And the other way around, any matter that we place inside this machine, your chart has to be appear on the screen, right? So if your chart doesn't appear, then there's no need for us to place it inside the machine. So how do you solve this type of question? You have to equate it down to 0. The reason is that we cannot divide anything on top here by 0, right? So when you divide by 0, it's not possible. That's why we are equating it down to 0. So the possible domain here is that x 2 plus s is equal to 0, meaning s is equal to what? Minus 2. Is that okay? S is equal to what? Minus 2 here. Now how do you write the domain? You write the domain in such a way that s, we are looking for s, whatever we are going to place inside the machine. And where are they coming from? X is coming from the set of real numbers, right? S is coming from this house. And then not every x except s is equal to what? Minus 2. Is that okay? So x, we are looking for s, right? So that s is coming from this house, except s is equal to what? Minus 2. We don't want s to be minus 2. What will happen? This guy is not part. If you don't know, you put this guy in your machine, then you are going to blast and what? Damage that machine. So we don't want this guy to be part of the machine. Is that okay? That's why we are taking this guy out. So this will be what? The set of what? All largest possible domain for what? This inverse function. If you've enjoyed the video, just subscribe to our YouTube channel, share the link so that we can support others as well. Thanks for watching.